your questions by then, I will do that. All right. So first question. Now, again, here's where it kind of gets into the specificity. So in this problem, the student gave me A, B, and C, and they said, we want to know like how to find secant. Now the problem is, or secant of theta. The problem is we don't know where theta is. And that's actually this is like a huge issue at this point. So let's go ahead and look at a triangle. Now, obviously, we know that 26 is going to be the hypotenuse because that's the largest side, right? The other two sides, it doesn't really matter. But let's just make the height 24 and this 10, okay? Now, let's say theta was right here. Okay, now we can go ahead and evaluate our trigonometric functions based on that angle. But our problem is we don't know if that's where theta was supposed to be because we didn't have a picture or the student didn't know where to reference. And that's why it's kind of like really important to understand these trigonometric ratios. They all depend on where the angle is, right? So when we're trying to evaluate the secant of theta, that means that the secant, which is really just a ratio, right? A secant is a way for us to compare. It's a comparison. But it's a comparison of sides of the triangle based on where theta is. So these are completely two different problems. I'm still going to use the same variable theta. But so in this case, if here's theta, remember secant. So actually, let's just do cosine. So cosine of theta, which is typically remembered a little bit easier for students, that is going to be adjacent over hypotenuse. So that's going to be 10 over 26. I'm not going to reduce that. I'm not going to simplify. Well, actually, I can. So, all right, fine. Cosine of theta, then you can reduce, divide by 2. That's going to be 5 over 13, right? Just go ahead and reduce that. I'll just write it like this. Okay. Well, actually, no, let's just leave it like that. I don't want to confuse people. They'll be like, look back at my notes, be like, what happened? So yeah, you can go ahead and reduce that, but we're just going to leave that from there. Now, the secant is just going to be the reciprocal of that. So that's going to be opposite over adjacent. But again, this is all based on where theta is. Here, theta is between the 10 and the 26, right? So here's the hypotenuse and here's the adjacent side. And that's a point I should probably make is remember when you have a triangle, a right triangle, you have the hypotenuse, which is always the largest side. The adjacent side is the side between the angle and the 90 degrees. And the opposite side is the side that is opposite of the triangle. So you can see why 10 for theta over here is going to be the adjacent side and 24 is the opposite. So the secant of theta is opposite over adjacent. All right. Now, however, I didn't know if that's what the triangle looked like or the triangle looked like this. See here, you can see theta is between the 26 and the 24. So now the opposite side of theta here is 10. So the adjacent side is 24 because remember 26 is always going to be there. So again, here we can just say the secant is going to be hypotenuse over adjacent. So to answer the student's question, I don't really know which triangle is there. So therefore I can't tell them what their answer should have been, but I can only say, well, based on where your theta is, these are your two answers that it's going to be. And again, but I think this is really important for everybody to take away from this is your trigonometric ratios, sine, cosine, tangent, tangent, cotangent, or sine, cosine, tangent, cotangent, cosecant, and secant. They depend on the angle. They are a comparison of sides of a triangle based on the angle, where that angle is in the triangle, because you have to understand the hypotenuse, the adjacent,